All right. So this time we got a line intersecting a curve that's upside down. The curve's upside down. Still intersecting in 2 points. Here's 1 at 3 comma negative 1. So that's one answer. 3, negative 1. Ah, come on. 3, negative 1. That's this point right here. The other point is over here where they intersect. That's a solution. 6 comma negative 4. Those are the two solutions to this set of equations, this system of equations. And that's it. Honestly, there's not much I could do with, even if I could write on this right now, other than like kind of put a little dot on those two dots right there. But same deal here. So what do we got here? This is intersecting at negative 9 comma 1, negative 9, 1, and negative 4, negative 4. Negative 4, negative 4. And that's it. All right, one more. We got 2-point intersection here. Negative 3 comma 6. That's one of them. Negative 3, 6. And over here we got 0 comma 3. 0, 3. All right. So that's those. Super easy. You're just identifying points. Second one also cool. It's the second one is like really just a strategy. And it's cool because it's multiple choice. You don't get those too often, right? On Delta Math. So this is the elimination method we're going to be getting into. And it's a nice intro to it. The whole goal of the elimination method is to eliminate or remove one variable completely. So you get down to one. Like basically we're going to get rid of these. And this is where I would really like to be able to write on this. But if we subtract this whole, well, all right, let me pause this. All right, so I'm gonna write these out, and I'm gonna show what happens here practically, what the whole purpose of this whole thing is. So we got 6x. You don't have to do all this. 5y equals 12, and 6x plus 3y equals 24. This is what we're going to, like, we'll be at, I don't know, tomorrow or something. If you take this whole equation and subtract the entire thing, again, you don't have to do this today. I just want you to understand why we're doing this. This is the elimination method. Then 6x minus 6x is 0. 5y minus 3y is 2y. Equals. 12 minus 24 is negative 24. So we would then have 2y equals negative 24. So y equals negative 12. And we can plug that back in and get the actual point of intersection. We're not doing all that today. All we want to do today is know that we would be subtracting to get rid of those x's. That's our whole point. Interesting. It won't let me go. So we'd be subtracting to get rid of those x's. All right. So that's our goal here. That's our whole idea. Subtract to eliminate x. That's it. You're not solving it at all. See, it shows the same thing. So again, like over here, this same deal. We would subtract to eliminate the x's. That's it. Subtract to eliminate x. Now I'll show you other examples so you see. Try to get one of each at least. Now look at this. Again, you want to remove one variable completely. Look at this. If I just add these two equations, this just disappears. Negative 2x plus 2x, gone. So this time we're adding to eliminate x. Voila. See, when you add those two equations, the x disappears. Beautiful. This is the elimination method. What about over here? Okay, now we can't deal with y. With x, we have to deal with y. So this time, even though they're minuses, if they're the same sign, you have to subtract to get rid of them. So here we're subtracting to get rid of y. And the y's disappear. Again, you don't have to do the work. You just have to tell which one. Over here, we're subtracting to eliminate y again. And there's only one we haven't done yet. We haven't added to eliminate y. So let's see if we can find one of those. There we go. So these, the y's are matched up, they disappear. So we are adding to eliminate y. And again, like tomorrow, we'll get into the actual like nuts and bolts of doing this. But that's it for now. That's all you have to do. So stop.